Welcome to Brain Vision.
Here we have a fireboat which discharges two streams of water from two different nozzles. We are given the volume flow rate and the nozzle velocity of each nozzle, and we want to calculate the tension in the anchor which is needed to secure the boat. So we can first use the steady flow equation and calculate the mass flow rate of the seawater at nozzles A and B. So the flow rate at A, the mass flow rate dma dt, is the same as the flow rate at nozzle B, dmb dt, and this is equal to the density of seawater, rho SW, times the volume flow rate, Q. The density of seawater is given as 1020 kg per cubic meter, and the volume flow rate is 0.25 for both nozzles. And so we get the mass flow rate to be 225 kg per second. Now, since the seawater is collected from the larger reservoir, which is the sea, the velocity of the seawater entering the control volume can be considered zero. And if we refer to the free body diagram, we can write the sum of the forces acting on the boat in the x direction. So we'll firstly take the left direction as positive and calculate the sum of these forces acting in the horizontal direction. So this is the flow rate at A dma dt times the speed in the x direction that the water leaves nozzle A, plus the exact same contribution at nozzle B, dmb dt times vb in the x direction. Now, the sum of the forces acting on the boat, since the boat is not in motion, is T cos 60 degrees, where T is the tension in the anchor, and it's what we wish to calculate. And this is equal to 225, the mass flow rate, times the x component of VA, which is 50 times the cosine of 30 degrees, plus the flow rate at nozzle B, 225 kg per second, times the x component of nozzle B's velocity, 50 times the cosine of 45 degrees. And so if we rearrange this equation, or essentially just divide both sides by the cosine of 60 degrees, we can solve for the tension in the anchor, and we get this tension T to be 40.1 kilonewtons.